Phosphorus is an essential element to life and drives the productivity of the global food system through its use as a fertilizer. Society's food security relies on phosphorus fertilizers that are sourced from non-renewable phosphate rock and used inefficiently. In fact, only 20% of mined phosphorus makes it into the human diet, leaving about 80% unaccounted for. So where does this 80% go? Some of it accumulates in terrestrial ecosystems such as soils, where it becomes chemically locked up and unavailable to nourish plants. Some of it makes its way into water bodies like lakes and rivers, leading to harmful algal blooms, fish kills, and unsafe drinking water. Since there's no substitute for phosphorus, we need to improve how we control, recover, reuse, and manage this very important element and nutrient. That's where STEPS comes in. Our team is working on new strategies and technologies to advance phosphorus sustainability. To address a problem as complex as this one, our conventional approaches just won't do.
Today's global challenges are too immense to be tackled by a single discipline. Phosphorus sustainability is one such challenge. We need new approaches in crop and soil science, wastewater management, environmental engineering, policy, and more. It's not enough for these disciplines to be working on solutions independently. Big, complex problems like this are best addressed through convergence. STEPS is integrating the knowledge, methods, and expertise of diverse fields, bringing together researchers with different backgrounds and perspectives to unite under one common goal. One place we need to start is by understanding how phosphorus flows into various systems.
Much of the phosphorus lost during the mining process and from our food systems ends up in our waterways. Where phosphorus is lost throughout the process is not exactly known. If we can identify the points where phosphorus is lost, we can better understand how to prevent it. In STEPS, our team is using computer models and isotopes to track sources of phosphorus in the environment at important urban, agricultural, and aquatic ecosystems throughout the United States. With computer models, we run simulations of how phosphorus and water move through the environment to try and recreate what we see in the real world. We use these models and retrace how phosphorus ended up in waterways. With isotopes, we collect measurements that can actually fingerprint the source of phosphorus, giving us important clues as to where phosphorus in a waterway originally came from, including sources like fertilizer and manure. But it's not enough to trace phosphorus to its source. We need to also capture it at the end of the cycle.
Because phosphorus reserves can be scarce in different parts of the world, but is essential for our food system, we must find new ways to recover phosphorus for reuse in agriculture. One under-tapped opportunity to do this is by recovering more phosphorus from human waste. However, current phosphorus retrieval processes from wastewater could be made more efficient and yield better quality phosphorus. Many wastewater treatment facilities use microorganisms to remove phosphorus in a process called enhanced biological phosphorus removal. However, the process often experiences upsets for reasons not well understood. When upsets occur, phosphorus can be released to the environment. Our goal is to understand what causes these upsets. With this knowledge, we can then develop solutions to prevent upsets. This work requires working closely with an important stakeholder for the solution: wastewater treatment plant managers. This is another important element of our center's convergence approach.
Engaging stakeholders in STEPS research is one of the center's core pillars. By rigorously engaging and interacting with stakeholders, STEPS research, decisions, and resulting outcomes will be able to better respond to and meet stakeholder priorities and needs. This in turn helps ensure STEPS achieve its 25 and 25 goals through strategic integration of stakeholder needs within the center's research while also enhancing adoption. My team studies how our different stakeholders view phosphorus sustainability and what they need to achieve sustainability. I also investigate and develop best practices to co-create sustainable solutions together with stakeholders in different contexts. Using these best practices, we also create guidance for the STEPS Center to develop effective collaborative efforts with external stakeholders. Overall, this works to help ensure that STEPS research and products of innovation align with stakeholder priorities while meeting their needs and also following principles of responsible innovation. All STEPS research across disciplines collects vast amount of data, and that data can benefit all of us.
Our convergence informatics teams aims to integrate data from all STEPS teams to enable new ways for the researchers to process, analyze, and interact with Phosphorus research data. STEPS data is being collected from materials discovery, device data testing, economic analysis, and then integrated using various approaches, including data mapping, fusion, data curation, and machine learning methods. We are developing a continuous workflow designed to gather and curate vast amounts of data on phosphorus from STEPS and from the literature, and then to consolidate everything in a single, publicly accessible knowledge hub. In addition, we are using machine learning algorithms to steer our team in the realms of discovery research. The Convergence Informatics project will provide resources to establish cross-platform interdisciplinary connections between the STEPS researchers, streamline the research process, enhance the accuracy of data, add a layer of decision-making indicators, helping to find optimal solutions in discovery of novel materials and technologies for use in manufacturing, agriculture, and environmental management. But STEPS is not only creating innovative scientific solutions, we also mentor innovative scientific mind.
One goal of STEPS is to recruit, train, and graduate a diverse group of researchers to be prepared to tackle the wicked problems of the future using a convergence research approach. After being part of STEPS for a year now, I am prepared to conduct research to help solve global challenges. My mentors in STEPS have helped me learn how to develop and evaluate a project for its application towards a pressing global issue. STEPS has also helped me grow as a researcher by giving me the opportunity to develop a highly collaborative research project idea. This is a difficult task when you only have expertise in one area, but I have now learned how to listen to what is being done in other fields and how to integrate them together with my project to develop a uniquely beneficial project with a real-world application.
As you've seen from our team, STEPS is a highly collaborative environment, bringing together a wide range of experts to tackle a wicked global problem. Visit our website or follow us on social media to stay up to date on our work or join our team.